let's talk equations. When we're doing mirrors and things, one of the things we can do is we can do ray diagrams, and we can actually measure a whole lot of distances. When we're doing ray diagrams, often we want to know the focal length. We want to know the distance to the object, and we want to know the distance of the image. Other things we want to know though is if we're using lenses, sometimes we use them in microscopes and telescopes and things, sometimes we want to know the focal length, we want to know the magnification, so magnification. Okay, so if you're looking just at the equation, magnification equals the distance of the image, the height of the image over the height of the object, which is also equal to the distance of the image over the distance of the object. And so this tells us if the image is bigger, we'll do an example in a second, or we'll do a whole series of examples shortly working on the height and magnification. The other thing is the relationship goes back a long way. 1 over f equals 1 over do plus 1 over di. And this works for lenses and for mirrors. So 1 over f, 1 over the focal length, is equal to 1 over do plus 1 over di. This is sometimes written f to the negative 1, or f inverse is equal to do inverse plus di inverse. And so if we want to work that out, we can go f is equal to do inverse plus di inverse, and then we just take the inverse of the whole lot. Also, when we're looking at, let's say we did our problem before, we had an object here, through the focal point, we ended up with an image here. There's often 3 pieces of information we want to know. So that's meant to be a straight line. If we're looking at this image here, is it upright or inverted? And we can look at that and we can tell that this one is upside down. Sometimes, like magnifying glasses, the image is the right way up. Sometimes it's upside down. Other things that we want to know, is it enlarged or reduced? And we can either use this equation here, or we can look at the picture and go, oh, that's smaller than that, so this is reduced. And the other one is real or virtual. And now this is it's probably technically conceptually the hardest of these 3 to understand. When we say real or virtual, what we mean is if I put a piece of paper here, will I see an image? Because if I have a magnifying glass or a lens, I can often see a picture upside down, pretty. But in this case, will I see an image there, or not? Or can I put a piece of paper there and shine it on there? And if the answer is yes, then it is real. If the answer is no, then it's virtual. And the easiest way, a quick and dirty way of determining this is when you use your ray diagram, you'll see this in the examples coming up. If we use solid lines, and these are all solid lines where they meet, then it's real. If we have to use dashed lines, and it's dashed lines that are meeting, then it's virtual. But we'll do that in the examples. Okay, so let's do some examples.